Okay, good morning. Welcome to Family Math, what, 358 maybe?
Yeah.
Okay. So this is a neat thing I saw from Kate Nowak and Dan Anderson during this week. And this is sort of advanced math. That's a little bit more than what you guys have seen already, but that's fine. But what I want to talk about is what the problem that Kate posted or wrote about. And then I want you guys to each come up with a question that you have about this problem, and then whatever your question is, we'll talk about that from one video each. Okay. So what this is, I'm going to switch this back to 0. What does this shape look like to you?
It looks like a curve.
It's a parabola.
Okay, it looks like a parabola.
Yeah.
And have you ever heard the word parabola before?
I think it's like some sort of curve.
Yeah, it is some sort of curve. You're right. And it's a special kind of curve. It's the graph of y equals x squared.
Y equals x squared.
Y equals x squared. I don't know if that's on camera or not, but y equals x squared. And so what does y equals x squared mean? This is the y-axis. This is the x-axis. So when x is 0, what is 0 squared?
0.
0. So we're at 0, 0. When x is 2, like right there, what is y?
Y is 4.
4, yeah, so it goes up to here about 4. When y is 4, how high would it go up?
Well, 16.
Yeah, you can see that's not even on the graph. Looks like the highest y value is 8, so it'll be way up here. Hey, what about when y is negative, or x is negative 2?
So wouldn't that would be 4?
Yeah, so you can see how it curves up. But what Kate posted about was actually kind of neat. She said, I'm going to rotate this 30 degrees counterclockwise. And now the graph looks like that. And you can see, you don't have to understand any of this, but you can see there's a little bit of math using something called sine and cosine that makes this work. But you can still see I have something and something squared, that same thing squared.
Yep.
And that's what that looks like. So we have something that you're probably used to seeing, or at least looks like something you've seen before.
Yeah.
A nice, perfectly nice little curve, and now we have it rotated 30 degrees. So my question for each of you is, what do you think about this? And what are some things you notice, or what are something that you might think would be interesting to talk about, following up a little bit more on this issue of rotating a graph?
Well, maybe you could look at some of the areas of, like this. You have these x-axis and y-axis lines, so some of them they intersect with the x-axis line. So, like, there's this part here, this part, and this tiny bit, and then this big bit, and then that over there.
Oh, and what would you like to do with those areas?
Well, like, what if you found the area of those areas?
Oh, wow.
That might be a really tough problem.
It might be, but yeah, let's definitely take a look at that, and let's see if we can figure out how we might find the area of some of those areas.
Okay.
That's a great question.
Sure.
High five. How about you? What are some things that you think might be worth interesting, or just a question that you have about this, or?
Well, what happens when the parabola is rotated 180 degrees, or like 270? It's like upside down parabolas.
Okay.
So you could rotate it 180 degrees.
The function never actually changes. Like y equals x squared, it's still a y equals x squared parabola. It's just moved over 30 degrees.
Okay. Yeah. So what is it? Give me a little bit more description of what you'd want to talk about.
Well, like, how does the function stay the same if you have to incorporate this 30-degree rotation?
Okay. Yeah. I think we can find something to talk about there. That's good. Okay. So we'll do the area first, and then we'll talk about yours second. Okay.
Okay.